In this video, we are going to cover 7.6, apply the sine and cosine ratios, day 1. Now, the sine and cosine ratios differ from the tangent ratio. So these are trigonomic ratios for the acute angles that involve the lengths of the leg and the hypotenuse of a right triangle. Now, remember tangent, we called that TOA. Tangent was opposite over adjacent, so it dealt with both legs. Now, we said so, ca, then it was TOA. So now we're going to see what these are. Notice both of these have the H because they will utilize the hypotenuse. Sine utilizes the opposite leg and cosine utilizes the adjacent leg. So let's look at this a little bit closer. It says let ABC be a right triangle with acute angle A. The sine of angle A, written as sine A, and the cosine of angle A, written as cosine A, is defined as the follows. Sine A is the reference angle, is the length of the leg opposite of A. So we will look opposite of A, and we will see that that is BC. The length of the hypotenuse we will see is AC. Now cosine is the length of the adjacent, so here's the adjacent to A, so that is AB, and the length of the hypotenuse is AC. So these two trigonomic ratios only work for the acute angles in the right triangle, and it will be the legs and the hypotenuse. So now let's find the sine and cosine ratios for number 1. It says write each as a fraction and as a decimal rounded to 4 places. First, let's do sine S. Sine S. Now, sine S, we have to look here, opposite over the hypotenuse. So this is equal to 60 over to 65. So opposite hypotenuse. Reduce this down by 5. We get 12 over 13. Take a calculator and then do this here. So we're going to take 12 divided by 13, and we are going to round this to 4 decimal places. So this is approximately 0.9231 if we round. Now, looking at cosine S, we do adjacent to S, which is 25, over the hypotenuse, which is 65. Reduce this down by 5, that produces a 5 over 13. Take that calculator again. 5 divided by 13, we will round this to the 4 decimal places again. So this is approximately 0.3846. So the key thing to remember with sine and cosine is it deals with the legs and the hypotenuse. So now let's look at number 2. It says find sine J and sine K round to 4 decimal places. So first let's mark J. Sine J is opposite over the hypotenuse, so 24 over 40. Reduce this one down, this time by 8, so that'll be 3 over 5. On the calculator, if you actually divide that out, that's going to be a 0.6 to prove that to you. 3 divided by 5 is 0.6. Now remember, we are rounding to 4 decimal places, so we have to add the digits in there. So this is going to be exactly 0.61230. Now, it also tells us to do sine K. So sine K. Now we're going to switch reference angles. Look opposite this time. That's going to give me 32 over the hypotenuse 40. This one also reduces down by 8. So this is 4 over 5. And on the calculator, that's going to give you 0.8. Add the 3 zeros. Now again, just little bitty details. This was equals because that's exact, approximately. I kept all of these equal, so those are exact numbers. Now, for you, I would like for you to pause the video and work number 3. Now, picking back up for cosine J, I hope that you marked J. This time you went adjacent, which is 15 over the hypotenuse. Type that into your calculator. You get approximately 0.8824. And then you are supposed to do cosine K, so this one here. Now 8 is adjacent and 17 is the hypotenuse, so you get approximately 0.4706. So, going back up to the very top of the notes, a few things that I want you to notice. Tangent deals with the legs. Since it deals with the legs, you can get a ratio over 1 because this leg can be bigger than this leg. So in a trigonomic chart, you will notice that the tangent ratios go over 1. Now let's talk about sine and cosine. We know from the behavior of triangles that the hypotenuse is the longest side of the triangle. And by rules of fractions, if the biggest number is on the bottom, these ratios will never go above 1. So if you look at a trigonomic chart, let's say like in the back of your book, then you're going to notice that those are always going to be under 1. Now, moving on, it says find the hypotenuse length. So it says you walk from one corner of a basketball court to the opposite corner. Write and solve a proportion using a trigonomic ratio to approximate the distance of the walk. Now, this time you now have 3 trigonomic ratios that you know. So part of the process now comes, which one do you use? And honestly, if you have different information, you can use more than one and still get the right answer. But if I'm looking at this one, I see the basketball court, and we're looking for the diagonal of the basketball court. We have a right angle. We have 62. And since I have 62, I'm just going to say, okay, what do I know? I do have an opposite of 62, and I do know x is a hypotenuse. So I go through so, ca, toa. So I automatically notice that sine is so. Now, you can do cosine if you know this angle by the third angle theorem, but since we already have that, we're just going to take the easiest way. So we are going to do sine 62 degrees equals opposite 94 over the hypotenuse x. Now these are going to solve just like you did with the tangent ratio. You are going to cross multiply. So pretend there's a 1 here, cross multiply. X times sine 62 degrees equals 94. To get x by itself, divide both sides by sine 62. Make sure that calculator is in degree mode. So right now I have x is equal to exactly 94 divided by sine 62 degrees. But it does say approximate the distance of the walk. So we will take a calculator. 94 divided by sine 62. Again, notice this right here. I am in degree mode. And I am going to get a number, and that is the distance of the walk. Now we consider this a leg length, well, it's a hypotenuse, but it's still a length. So we're going to round this to approximately 106.5 feet. So your new task with this lesson is to do what you know how to do, but just know which trigonomic ratio to implement. Okay? Now, moving over to number 5. It says a guy wire, which is this thing right here, reaches from the top of a 120-meter cell phone tower to the ground. The wire makes a 68-degree angle with the ground. What is the length of the guy wire? Now, For this one, I would like for you to pause the video, just like we've been doing. You will enter your answer in for this one, so make sure you follow number 4 to help you get number 5.